In accordance with the National Electrical Code, a separate grounding bar must be used for the ground wire in a manufactured home electrical system. National Electrical Code Article 550.16(1) B states that in manufactured homes, the grounding bar shall be separate from and bonded to the neutral bar only at the service equipment. The ground wire, identified as green or bare copper, must be connected to a dedicated grounding bar. The neutral wire, which is white or grey, must be connected to a separate neutral bar. Both the ground and neutral bars must be bonded together only at the main service panel or disconnect. When wiring a meter on a pole with a disconnect for a 4-wire manufactured home system, firstly, install a separate grounding bar next to the neutral bar. Secondly, connect the ground wire to the grounding bar. Thirdly, connect the neutral wire to the neutral bar. Fourthly, bond the grounding bar and neutral bar together at the main service panel or disconnect. Failure to follow this code requirement can create a safety hazard and may result in incorrect grounding and potential electrical problems. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is updated every 3 years. The NEC is a comprehensive document. It is essential to consult the latest edition and related resources for specific applications. Grounding and neutral are two distinct concepts in electrical systems. Grounding provides a path for fault current to return to the source, tripping a breaker or fuse and energizing the circuit, while neutral carries the imbalanced current in a 3-wire or multi-wire circuit back to the source. The purpose of grounding is to provide a low-impedance path for fault currents. This path allows for the rapid clearing of a fault by tripping a circuit breaker or blowing a fuse. Without proper grounding, fault currents could travel through unintended paths, such as metal enclosures or equipment, posing a shock hazard. Grounding also helps to stabilize voltage to earth during normal operation. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the grounding conductor, which runs back to the service panel. At the service panel, the grounding conductor is bonded to the neutral conductor, creating a single point where the grounding and neutral systems are connected. This bonding ensures that any fault current will have a low impedance path back to the source. The neutral conductor carries the unbalanced current from the load back to the source. In a balanced 3-phase system, the neutral conductor would carry little to no current. However, in most electrical systems, the loads are not perfectly balanced, so the neutral conductor is necessary to carry the difference in current between the phases. The neutral conductor is typically identified by its white or grey insulation. The NEC specifies that the neutral conductor must be insulated to prevent accidental contact with grounded surfaces. The size of the neutral conductor must be sufficient to carry the maximum unbalanced current that is likely to occur in the circuit. In a manufactured home, the electrical system is often supplied by a 4-wire system, which includes 2 hot wires, a neutral wire, and a grounding wire. The 2 hot wires are typically 120 volts each, and they are 180 degrees out of phase with each other. This allows for the use of 240-volt appliances, such as electric ranges and dryers. The neutral wire provides a return path for the 120-volt circuits, and the grounding wire provides a path for fault currents. The NEC requires that the grounding and neutral conductors be kept separate throughout the manufactured home except at the service panel. This is to prevent the flow of neutral current through the grounding system, which could create a shock hazard. The grounding and neutral bars must be bonded together at the service panel to provide a single point where the grounding and neutral systems are connected. This bonding ensures that any fault current will have a low impedance path back to the source. When wiring a meter on a pole with a disconnect for a 4-wire manufactured home system, it is important to follow the NEC requirements for grounding and neutral connections. Firstly, install a separate grounding bar next to the neutral bar in the disconnect enclosure. Secondly, connect the ground wire from the meter to the grounding bar. Thirdly, connect the neutral wire from the meter to the neutral bar. Fourthly, bond the grounding bar and neutral bar together at the main service panel or disconnect. This bonding can be accomplished by using a bonding jumper, which is a conductor that is sized according to the NEC. The bonding jumper must be connected to both the grounding bar and the neutral bar. It is important to use the correct size bonding jumper to ensure that it can carry the maximum fault current that is likely to occur. Failure to follow these requirements can create a safety hazard and may result in incorrect grounding and potential electrical problems. Incorrect grounding can lead to electrical shock hazards, equipment damage, and fire. It is essential to ensure that the grounding system is properly installed and maintained. The grounding system should be inspected regularly to ensure that all connections are tight and that there is no corrosion. If any problems are found, they should be corrected immediately. The NEC provides detailed requirements for grounding and bonding electrical systems. It is important to consult the NEC and related resources for specific applications. Some additional considerations include the size of the grounding and neutral conductors, the type of grounding electrode, and the location of the grounding electrode. The size of the grounding and neutral conductors must be sufficient to carry the maximum current that is likely to occur in the circuit. The type of grounding electrode must be appropriate for the soil conditions. The location of the grounding electrode must be in an area where it will be in contact with the earth at all times. In some cases, it may be necessary to install multiple grounding electrodes to ensure that the grounding system is effective. Grounding electrode conductors must be sized according to NEC Table 250.66. A common size for a copper grounding electrode conductor is number 6 American wire gauge, or AUG. However, the size may need to be larger depending on the size of the service entrance conductors. The grounding electrode conductor must be connected to the grounding electrode using a listed connector. The connection must be accessible for inspection and testing. Ground rings are another type of grounding electrode. They are typically used in areas with poor soil conditions. A ground ring is a continuous loop of bare copper conductor that is buried in the earth. The ground ring must be at least 20 feet long and must be buried at least 2.5 feet below the surface of the earth. Concrete encased electrodes, also known as grounds, are another type of grounding electrode. They are typically used in new construction. A concrete encased electrode is a bare copper conductor that is encased in concrete. The concrete must be in direct contact with the earth. The NEC provides specific requirements for the installation of concrete encased electrodes. The NEC also provides requirements for bonding different metal parts of the electrical system together. Bonding is the connection of metal parts to create an electrically conductive path. Bonding helps to reduce the risk of electric shock by ensuring that all metal parts are at the same potential. Bonding conductors must be sized according to NEC Table 250.102. A common size for a copper bonding conductor is number 8 American wire gauge, or AUG. However, the size may need to be larger depending on the size of the service entrance conductors. Equipment grounding conductors are used to connect metal enclosures of electrical equipment to the grounding system. Equipment grounding conductors must be sized according to NEC Table 250.122. A common size for a copper equipment grounding conductor is number 12 American wire gauge, or AUG. However, the size may need to be larger depending on the rating of the overcurrent protective device. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock. GFCIs monitor the current flowing in the circuit and trip if there is a difference of 5 mA or more between the current flowing to the load and the current returning from the load. GFCIs are required in many locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or RFCIs, are devices that are designed to protect against fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when there is a break in the insulation of a wire. RFCIs monitor the current flowing in the circuit and trip if they detect an arc fault. RFCIs are required in many locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, and other events. SPD divert the surge current to ground, protecting the equipment from damage. SPD are available in a variety of types and sizes. They can be installed at the service entrance, at branch panels, or at individual pieces of equipment. It is important to select an SPD that is appropriate for the application. The NEC provides requirements for the installation of SPD. The NEC also provides requirements for the inspection and testing of electrical systems. Electrical systems should be inspected regularly to ensure that they are safe and in good working order. Inspections should be performed by qualified electrical inspectors. Testing should be performed using appropriate test equipment. Testing can help to identify potential problems before they become serious. The NEC is a complex document. It is essential to consult the latest edition and related resources for specific applications. Proper grounding and bonding are essential for electrical safety. Failure to follow the NEC requirements can create a safety hazard and may result in incorrect grounding and potential electrical problems. Always consult with a qualified electrician for any electrical work. Electrical work can be dangerous and should only be performed by qualified individuals. Remember to always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment such as gloves and safety glasses. Work safely and follow all applicable codes and regulations. By following these guidelines, you can help to ensure the safety of yourself and others. Electricity is a powerful force. It is important to respect it and to take the necessary precautions to prevent accidents. Staying informed about electrical safety and adhering to established codes and standards is crucial for preventing hazards and ensuring the reliable operation of electrical systems.